All right, so I think I'm recording. Let's take a look at this word problem. It's a mixture problem, but it's slightly different than other mixture problems. The lab assistant needed 20 ounces of a 10% sulfuric acid. If he has 20 ounces of a 15% solution, how many ounces must he draw off and replace with distilled water in order to reduce it to a 10% solution? So these type of problems have a fixed size container. Oftentimes they also are changing the concentration of antifreeze in a radiator in a car, where you can't just change the size of a radiator. That container is a fixed size. So this is the type of problem that we have here. We want to do this by two different methods, or at least I'd like to do it by two different methods to illustrate. And I'm calling these methods, the first method, I'm referring to it as the bucket method, and the second method, I'm going to refer to it as the seesaw method. And it's just giving you two different ways to try to view and solve this problem. So if I think of buckets, I've got this one slightly different than others. The bucket is a fixed size. So here's a bucket that is representing a solution, and then here's the same size bucket and the same size bucket and the same size bucket. All right, so how am I going to use this idea, my illustration here, to help me get an equation? What we need to come up with as a final answer is a 10% solution, and what we're measuring is sulfuric acid. So this liquid is 10% sulfuric acid, and it's 20 ounces. Well, like I said, that 20 ounces, each of these is the same size container, so all of these have 20 ounces. And that's different than other mixture problems where I'm free to get, if I'm in a kitchen making salad dressing, and I'm free to go over and get a larger size container to mix my salad dressing. But at times, sometimes, like in the case of a radiator in a car, the size of the container is a fixed size. Excuse me. So let's continue. It says that we have started off with 15%, and we have this 15%. Well, this solution apparently is too strong. We want to weaken this solution. We want a 10% solution. So what we're going to do is drain. We're going to draw off. We're going to drain some of this 15%. Maybe you're just walking over to the sink and pouring part of this 20 ounces down the sink. So even though the container was 20 ounces, I'm going to change my volume at the bottom. That was the maximum size of this container. Well, I'm removing some of this liquid from this 20 ounces, so I have to figure out how many ounces I'm going to remove. I'm not going to, it's unlikely that I'm going to pour the whole 20 ounces down the drain and then refill it with a 10%. That's an expensive way to do it. So, here you can imagine a water level being up at the top of this container, and when you drain some of it off, that water level has now gone down, and you're going to fill it back up to the rim with a weaker solution. So the amount that we're draining is going to be the amount that we replace. But what we're replacing it with is something weaker, in order to dilute this concentration. Okay, the best way to dilute it would have been to have added pure water. Oh, I'm sorry, I did look at this. I misread the problem. And we are diluting it with pure water. So read the problem carefully. All right. So in this fixed bucket, in this drain and replace type of problem, you have 20 ounces. You're going to remove part of that 20 ounces that is a 15% solution, and you're going to replace it with a weaker concentration. In fact, the weakest it can get, this distilled water, this pure water, and that's going to weaken the concentration from 15% to 10%. All right, so there's our picture that illustrates how we want to set up our equation. We know from previous problems and examples in class that we want to take the concentration times the volume. So we've got 15 times 20. And the idea of draining something relates to subtraction in an equation. So we're draining part of this 15% solution off and replacing it. We're adding water. Now 0 times x is not changing my numerical value, but I'm just putting that in as a placeholder to just help me visualize what's going on in the problem. And then I've got 10 times 20. So now I have one equation and one unknown, and I can solve for this. So 15 times 20 is 300 minus 15x. That's 0. And 10 times 20, 200. So if I subtract 300 from each side, and if I divide by a negative 15, the negative divided by negative cancels, and 115 share a common factor at 5. So I have 20/3 ounces, and that's of that. Well, we'll write a sentence that describes what our final answer represents in just a second, and we'll use that summary for both of these methods, because both of these methods are going to produce the same answer. All right, so let's now try to do the same type of problem with our idea of the seesaw. And remember, the idea of the seesaw, if you've ever been to a park and a seesaw, if you have a light object person and a heavy person, you can balance a seesaw if the heavy person is a shorter distance to the fulcrum, if the light person is a longer distance where that light person has more leverage. That's the underlying idea. And both of these ideas, both of these methods rely on the fact that you realize that the final concentration is in the middle, is in between your what you started with, say, and what you're either adding to weaken or dilute the solution. So that's how I kind of start this seesaw method, is to identify the concentration of my weak solution, to identify the concentration of the solution that's in between the weak, and that call the other solution the strong solution. So in this problem, we had distilled water, which our concentration is measuring the amount of sulfuric acid. So the weak solution had no sulfuric acid, that was 0%. We wanted to obtain a 10% solution from this 15% solution. So when we set this up, these numbers are always going to be increasing order, if we started with the weak, then the one that's in between, and then the strong. All right, now what we want is the volume of each of these. So we do not know how much water we're going to add to um, dilute this concentration. So that's our variable x. For this for this 15% solution, we have to write it as a binomial. We know that we started out with 20 ounces, but we removed some of that to make place for the water. So the volume that we end up with is 20 minus x. So now we want to look at the distance to the fulcrum. On the seesaw method, how far away from you are you from that balancing point? Well, from 0 to 10 is 10 units away, and from 10 to 15, 5 units away. So if we think of the equation as weight times distance, or maybe we should say volume times distance. In the seesaw, it's weight, but here the volume is analogous to the weight. So on the left we have 10 times x, and on the right we have, excuse me, 5 times 20 minus x. So we have one equation and one unknown. Let's solve for this x. And we know that we should get 20 over 3 as our final answer, because x represented the volume of, well, we'll talk about what it represented here in just a minute, but it's representing the same thing for each method. 5 times 20 is 100 minus 5x. Let's add 5x to each side. We have 15x is equal to 100. Divide by 15. 115 share a common factor of 5. So this reduces to 20 over 3 ounces. All right, so let's make some type of a summary of our answer for these two methods. So, what if I can type it? I can. Okay, I didn't know that. So the lab assistant must drain, and I think it said draw off. I always say drain. 20/3 of an ounce of the 15% solution. Now my writing skills are not the best, so my sentence you may be able to write a better sentence. The lab assistant must drain 20 over 3 ounces of the 15% solution and replace it with the same amount, 20 over 3 ounces of distilled water. To obtain the desired solution, or something like that. All right, will that insert in there? Okay, it does. It's kind of long. I don't know. It's off the page. I wonder. Wonder if you can edit it. Oh well, you saw me type it in. You can pause the video. I'll play around with it and learn how to do it later. So there's two different methods to solve the same problem. I hope that helps, and I will talk to you later. Bye.